Hello students, myself Sooryaraj, Faculty of Physics. Today we are going to discuss the third application of dimensional analysis to derive unknown relations. So now I am going to derive the time period of a simple pendulum. Okay, so we are going to derive the time period of a simple pendulum. For that, assume that this is only an assumption. Time period of a simple pendulum may depend upon mass, length and acceleration due to gravity. This is our assumption. We have to assume that time period of a simple pendulum may depend upon mass of the bob, length and acceleration due to gravity g. And we can put the powers of these quantities as A, B and C. The power of mass is taken as A, the power of length is taken as B and the power of G is taken as C. We have to find the value of A, B and C. We have to find that. For that we can take dimensions on left side and right side. On left side, the dimension of time, that means there is no mass. So m raised to 0, there is L raised to 0 and T. This is the dimension of time. So dimension of time is represented below, that is m raised to 0, L raised to 0 and T. Okay. So on the right side also we can take the dimension according to principle of homogeneity. On both sides each and every quantities should have the same dimension. So on left we have to take the dimension of time, that is m raised to 0, L raised to 0 and T raised to 1, simply T. On the right side we have to take the dimensions m. The dimension of mass is nothing but m raised to a. The first quantity is over. Okay. Dimension of length. Dimension of length is L. Raised to the power is B. So second quantity is ready. And the third thing is G. What is G? G is called as acceleration due to gravity. What is acceleration due to gravity? Acceleration and acceleration due to gravity show same dimensional formula. So for acceleration due to gravity, we can take the dimension same as that of acceleration. So what is the dimension of acceleration? L t raised to minus 2 raised to c is there. The first step is over. What is the first step? Taking dimensions on left side and on right side. On left side you can see time. The dimension of time is nothing but m raised to 0, L raised to 0 and T equal to. On the right side you can see three different entities. They are mass. Dimension of m raised to the power is A. L raised to B. G means acceleration due to gravity. The dimensional formula of acceleration due to gravity is nothing but that of acceleration. That means L t raised to minus 2, all raised to c is there. Now I have to open these brackets. We are going to open those brackets. So on left side there will be no change. M raised to 0, L raised to 0, T equal to. On the right side we are opening the bracket m raised to A, L raised to B, then we can open the bracket L raised to C and T raised to minus 2 into C minus 2C. Okay. So now we have opened the bracket. M raised to A, L raised to B, L raised to C, T raised to minus 2 into C minus 2C. Now we can do one more step. M raised to 0, no change. L raised to 0 t. On the left side, we will not make any change. On the right side, we have to make the change. M raised to a, L raised to b into L raised to c. We can add the powers b plus c and t raised to minus 2c. Okay. So now we have added L raised to b into L raised to c. We can add the powers L raised to b plus c. Now, according to principle of homogeneity, we can find the value of a, b and c. Now we are going to find the value of a, b and c. It's very easy. On the left side, the power of mass is a. On the right side, the power of mass is a and the corresponding power is 0. So I can write a is equal to 0. A is equal to 0. Now we can check that of L. Before the L, we can take t. On the right side, the power of t or the dimension of t is minus 2c. On the right side, the power of t or dimension of t is minus 2c. On the left side, that is 1. So I can write one more thing, that is minus 2c equal to 1. If minus 2c is 1, c is equal to minus 1 by 2. Okay. Now we can take the another quantity, that means on the right side the dimension of or the power of L is b plus c. On the left side that is 0. So I can write b plus c is equal to 0. B plus c is equal to 0. But c is minus 1 by 2. C is minus 1 by 2. But b plus c is equal to 0. So what will be b? The value of b will be plus 1 by 2. So now I obtain a, b and c. How a, b and c can be calculated? In which method we can calculate a, b, c? By using dimensional analysis. On the right side, the dimension of the power of m is a. On the left side, that is 0. So I can write a is equal to 0. On the right side, the power of t is minus 2c. And on left, that is 1. So minus 2c equal to 1. So c is equal to minus 1 by 2. Okay. Then on the right side, the power of L is b plus c. On the left, that is 0. So b plus c is equal to 0. But c, the value of c is minus 1 by 2. So b should be plus 1 by 2. Now I can give these quantities here. T proportional to m raised to a. A means 0. L raised to b. B means 1 by 2. And g raised to c. G raised to c is minus 1 by 2. Okay. So let us continue. Then we know that m raised to 0, that is 1. So this quantity can be neglected, that is 1. So t proportional to L raised to 1 by 2. G raised to minus 1 by 2. We can take another step, t proportional to L raised to 1 by 2 is there, L raised to 1 by 2. When g raised to minus 1 by 2 is taken into denominator, it becomes g raised to plus 1 by 2. When g raised to minus 1 by 2 is taken into denominator, it becomes g raised to 1 by 2. Raised to 1 by 2 means root. So proportional to root of L by G. Here this proportionality should be converted into equation. To convert proportionality into equation, we have to multiply it with a constant. The value of constant here it is 2 pi. So, t is equal to, we have to multiply with the constant 2 pi, the balance is root L by G. This is the expression for time period of a simple pendulum. Okay, so by using dimensional analysis, we can find the equation, the expression for time period of a simple pendulum. What is the final equation? T is equal to 2 pi root L by G. So, thank you. See you in next class.